The quantum superposition. The enigmatic quantum world discovered by the German physicist Max Planck opened a door to a fascinating, wonderful, incredible reality, but very difficult to know, due to its dimensions foreign to human senses, its anti-intuitive behavior, its incalculable limits. They are an insurmountable barrier for those not specialized or alien to quantum mechanics. However, the human mind can be stranger than physical quantum reality, given that we have a non-material dimension of which we are part, and that we urgently need to know, and that, with a strange curiosity, does not push us to try to understand the world and the universe in which we live. This video is a small part of a work that is synthesized in a theory, development by information. In this theory, it is speculated that the universe is determined and is made up, in addition to matter, of an immaterial factor. Some principles of quantum reality, if true, nullify the probability of a non-material reality, since they solve the fundamental equations of the universe through the matter factor. Quantum superposition is related to this purpose. The simplest way to understand quantum superposition is through the thought experiment of Austrian physicist Erwin Schrödinger 1935, known as Schrödinger's cat. To explain quantum superposition, he puts a cat in a box which, being in a quantum superposition, can be alive and dead at the same time. To know if he is alive or dead, you have to open the box. The concept takes us to another level, that of maintaining that in quantum reality there is an X quantity, or all the probabilities that can happen and that define it. Therefore, the universe and everything in it is as it is solved with a probability equation. The problem is when the probabilities need to repeat a pattern, one as if it were a mandate, given that in the universe there are laws and constants that if the same mathematical probability is used would disprove it. As for the dead or alive cat experiment, there are only two probabilities. Is this thought experiment correct? There is a very important point that I have not found to be taken into account in the experiment, and it is nothing less than the time factor. The time factor is essential to understand the probability of a quantum superposition occurring, since superposition refers to the states in which a particle would be found. For the cat thought experiment, the probable states are live cat or dead cat. The point is that superposition of states does not imply superposition of times. In this case, probability has two forms of conversion, one in temporality, the other in energy. In principle, the form of temporality will be seen. Therefore, probable states can be converted into times. A time where the cat is alive, and another time where the cat is dead. The point is that probability converted to temporality has only one meaning, since time goes forward and not backward. Therefore, from a live cat it can go to a dead cat, but it cannot go from a dead cat to a live cat. The arrow of time would not allow it, because time is an essential factor in understanding the structure of the universe. Said experiment would not be contemplating the importance of temporality. Another form of conversion of probability, I understand that added to the view, allows reasonable doubts that would question the veracity of the principle. It is converting probability into energy and taking it to an equation. For this I am going to use the same Schrödinger box. I am going to take out the cat that is dead after being in the box for so long. I am going to make a modification to the box. I will make it larger so I can place a bow that shoots arrows. The peculiarity is that the bow is double and with a double arrow, one of the points facing the left and the other facing the right. The probability has to be equal for it to make sense, given that if the probability, no matter how small, is more on one side than the other, the experiment would not make sense. The same thing happens with the live and dead cat. If the probability is not exactly equal, or whether the cat is more likely to be alive than dead or vice versa. If the probability is not exactly the same, why do the experiment? For this reason, the equality of probability, carried to the arc, can be converted into energy. By transforming it into energy, probability becomes an antinomy that nullifies quantum reality. Why I maintain that quantum superposition becomes an antinomy? Because if you give a specific energy value to the probability of the arrow shooting left or right, the same force is needed. So, if we have an energy value of 28 pounds pushing to the left and 28 pounds pushing to the left, the forces cancel each other out. Stop this case, contrary to what Schrödinger maintains in his experiment, in which you have to open the box to know if the cat is alive or dead. If the probabilities are converted to energy, it is not necessary to open the box. In this case, to know where the arrow will go, since these energies cancel each other out and remain in balance. There is a game, tug of war, that is usually played, where a group of people pulls one way and another against it. Suppose it were the case that both groups exerted the same force, so neither would advance or retreat. The same thing happens with quantum superposition when it is converted into energy. The truth is that in order to understand a little more about what was said, a base can be established that gives us the greatest probability. The greatest probability is that quantum reality is energy. The states in which they are found are interpretations, since there are many around quantum reality. So, if you think about energy, the superposition must be cancelled. The concept of hidden variables raised by Albert Einstein does not seem to be a finished discussion. However, they would have to be found to be adequately justified in order to accurately determine quantum activity. There is a question that needs to be asked, given that there is currently a technology that applies quantum superposition. It is precisely quantum computing, so it could be used as a counterargument. However, a technology based on quantum superposition can be made for a simple reason, without that reason being something that happens in nature. The explanation is simple, given that the technology that attempts to use quantum superposition, qubits, they are units of information that represent something, zeros and ones, and are not units of energy with specific values. Given that if the qubits were units of energy, they would simply not work, as was already seen in the ARCS experiment when probability was converted into energy, an antinomy was generated. That would not happen in qubits because, as I already said, they are units of information that work with probability. Going off topic a little, in the theory of development by information, as opposed to quantum superposition, reality is interpreted as a superposition of planes, as if they were layers of onions, but it is only analogical. Since the universe does not need to be managed that way, the plans are conceptual. However, they exemplify how different realities could coexist. Since the sum of macro reality, which we experience every day, is different from the sum of quantum reality that is managed with other laws. But the universe is one, and we are connected and interacting. Therefore, the probability of quantum superposition raised in Schrödinger's cat experiment or the uncertainty principle by Werner Heisenberg. It could just be some pieces that make up the gear. I understand that if the context is not understood, the parts could not describe the whole, especially when we do not even know what the whole is. Quantum superposition is one of the topics discussed in the theory of information development. For those interested, you can search for it in the Amazon store. Qualification: Information Development Theory. Author: Pedro Roman Bermejo.